payments just went from 0.1% errors to 100%. A single unvalidated string crashed the entire charge endpoint. Let's break down input validation in Node.js with Zod, how it works, and the exact mistake behind that failure. Input validation is like a bouncer at a club. Zod checks everyone's ID before letting them in. It ensures data shape, types, and constraints, preventing garbage from corrupting your database. Many Node.js apps rely on manual checks in root handlers. This leads to inconsistent errors and missed edge cases. A single unvalidated field can crash a service. Zod provides a centralized validation layer. Here's a typical manual validation. It checks types and presence, but misses type coercion. A string, 25, passes the type-off check but breaks later. This is why we need a schema-based approach. Zod schemas are the single source of truth. They validate at runtime and generate TypeScript types automatically. No more manual interfaces that drift apart. This schema defines a user with required name, valid email, and optional positive integer age. The inferred type matches exactly, so refactoring is safe. In Express, we create a validation middleware that uses safe parse. If validation fails, we return a 400 with field-level errors. If it passes, we replace rec body with the parsed data and call next. This middleware factory takes a schema and returns a middleware. It uses safe parse to get a result object, then either returns errors or proceeds. This keeps root handlers clean. HTTP requests often send data as strings. Zod's coerce automatically converts types, and transform lets you clean data like trimming or lowercasing. This reduces boilerplate. Here, page and limit are coerced from strings to numbers. Email is transformed to lowercase. This ensures consistent data formats without manual parsing. Real-world data is nested. Zod handles this with nested objects and arrays. Error messages include the full path like items 0, quantity, making debugging easy. This order schema validates a nested items array and an optional shipping address. The min1 ensures at least one item, preventing division by 0 errors. Sometimes built-in validators aren't enough. Zod's Refine lets you add custom logic, like checking start date before end date. For async checks, use superRefine, but be careful with performance. The dateRange schema uses refine to ensure start is before end. The async superRefine checks a database for username uniqueness. Use async refinements sparingly to avoid latency. Zod's default error format is an array of issues. For production, transform it into a per-field error object. Log the full error for debugging, but return a sanitized version to the client. This function converts Zod issues into a nested object with field paths as keys. The client gets a clean response like errors, email, invalid email. Validation adds overhead, but Zod is fast. Use safe parse for better performance. Profile your code. If validation is a bottleneck, consider pre-validating at the edge or simplifying schemas. You can benchmark your schemas like this. In most cases, validation is not the bottleneck. Only optimize if profiling shows it's a problem. Schemas are code and should be tested. Write unit tests for valid and invalid inputs and verify error messages. This catches regressions when schemas change. These tests verify that the schema accepts valid data and rejects invalid data with the correct error path and message. Run them in CI to prevent regressions. Zod's type inference is its killer feature. Change the schema and TypeScript flags all usages. Use strict to reject unknown keys, preventing data leakage. With strict, any extra field like extra causes validation to fail. This prevents mass assignment attacks and accidental data leakage. Monitor validation failures to detect client bugs or attacks. Log enough context to debug, but avoid sensitive data. Set up alerts for spikes in validation errors. This middleware logs validation failures with endpoint, method, and IP. Use this data to monitor trends and alert on anomalies. Migrating from Joy or Yup to Zod is straightforward. Zod's API is more consistent and TypeScript friendly. Start with new features and gradually replace old schemas. The Zod equivalent is similar, but provides automatic TypeScript types. Note that Zod's min1 rejects empty strings, while Joy's required allows them, catching latent bugs. For complex workflows like payment processing, use discriminated unions with a single superRefine that switches on the type. This keeps validation co-located and type-safe. This schema validates credit card and PayPal payments. The superRefine adds variant-specific checks, card expiry, and PayPal email domain. This pattern scales to many variants. Separate validation into 2 layers: boundary schemas for shape and types, and domain logic for business rules. This makes code more maintainable and testable. The boundary schema validates shape and types. The domain function checks business rules like age and email uniqueness. This separation reduces schema complexity. In a monorepo, share Zod schemas between frontend and backend. This eliminates duplication and ensures both sides validate the same way. Use workspace dependencies to import. Here, the user schema is defined once in a shared package. Both the backend API and frontend form use it, ensuring validation is consistent across the stack. For edge environments where bundle size matters, consider Valibot. It has a similar API to Zod, but is tree-shakeable, resulting in much smaller bundles. Valibot uses functions instead of chaining, but the concept is the same. It's a great choice when you need to minimize bundle size for edge functions. This is the same issue we highlighted at the start. Here's exactly why that happened. The charge endpoint did not validate the amount field. A client sent amount, 100, as a string. The payment software development kit expected a number and called amount to fixed 2, which threw a type error. This unhandled exception crashed the Node.js event loop because there was no try-catch. The amount field received a string instead of a number. Causing amount to fixed is not a function crash. Adding a Zod schema with znumber and SafeParse prevents this by validating the type before use. The fix was to add a Zod schema that validates amount as a positive number. Using SafeParse, we return a 400 with errors if validation fails. We also added a global error handler to catch any remaining unhandled exceptions. This prevents the crash and gives the client a clear error. This is the exact code that caused the incident. The amount field was not validated, so a string slipped through and caused a type error. Always validate at the boundary. Without strict, Zod allows unknown keys including proto. This can lead to prototype pollution attacks. Always use strict on schemas parsing external input. z.coerce.boolean only accepts the exact strings true and false. Any other value like 1 or yes throws an error. Use a custom preprocessor for general truthy/falsy conversion. Validate environment variables at startup using Zod to fail fast on misconfiguration. This ensures all required envars are present and correctly typed before the app serves requests. This article uses Zod v3 syntax. In Zod v4, expected late 2025, SafeParse returns a discriminated union with success and data error properties, and strict is the default for objects. Check the Zod changelog when upgrading. For nested data like comments or categories, use zlate to define recursive schemas. This allows a schema to reference itself, enabling validation of deeply nested structures without infinite loops. To debug validation issues, log failures with context. Use structured logging to analyze patterns. Profile validation duration to identify slow schemas. Set up alerts for high error rates. Let's run through some common interview questions. What is Zod and why use it? TypeScript first schema validation with automatic type inference, reducing duplication and bugs. How does SafeParse differ from parse? Parse throws on error. SafeParse returns success data error for graceful handling. How to create custom validation? Use Refine for synchronous checks, superRefine for async with access to context. How to validate nested objects. Nest zObject inside zObject. Use zArray for lists, error paths include full path. And a few frequently asked questions. How to validate query params? Use z.coerce to convert strings then parse rec, query with schema. Can Zod validate async? Yes, with superRefine, async function, but be cautious about performance. How to reject unknown keys? Use strict on object schemas to reject extra fields. What's the difference between Zod and Joy? Zod is TypeScript, first with type inference. Joy is JavaScript, only with manual types. Let's recap the key takeaways. Use Zod schemas as single source of truth. Leverage coerce and transform. Use strict to prevent prototype pollution. Separate boundary and domain validation. Ready to go deeper? Up next, API documentation with Swagger and OpenAPI in Node.js, then Mongoose ODM for MongoDB in Node.js, then PostgreSQL with Node.js, and Prisma ORM with Node.js. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.